Resistors are special components of electric circuits made for providing a specific amount of opposition to the flow of electric current. Resistors are very useful in modern electronics. For proof of this, check any printed circuit boards from used or discarded electronics around you, and you will find several visible resistors on them. They usually look like small tubes or cylinders with two wires protruding from their sides. And this does not include the number of resistors inside the black chips on the board. Now, resistors come in different types and are made from different materials. And resistors can have constant or variable resistance values. Resistors with a constant resistance value are sometimes known as standard resistors and are represented with a box that has two lines protruding from its sides. Variable resistors are resistors whose resistance can be varied within a defined range. Variable resistors are represented by the resistor sign with an arrow across it. Examples of variable resistors include potentiometers, rheostats, the resistance box, thermistors, magnetoresistors, photoresistors, humistors, and force-sensitive resistors. They are very useful for many practical applications where a varying resistance is needed. And these include motion sensors, home electrical appliances, audio control, etc. Resistors can be made from different materials. These include metallic wires, metal oxide films, metal foils, and so on. So let us talk about two variable resistors commonly used in the laboratory: the rheostat and the resistance box. The rheostat is a variable resistor often used in the laboratory to control current or vary the resistance in a circuit. It consists of a resistance wire wound around an insulating frame, a slider which makes contact with the resistance wire at various points, and a brass rod on which the slider is hung. The slider determines the length of the resistance wire that is used to create a variable resistance in the circuit. By moving the slider, you vary the resistance supplied to the flow of current through the rheostat. Now, a resistance box is simply a box of resistors, kind of. It actually contains several standard resistors with their various ratings. The total resistance supplied by the box is equal to the sum of the resistors plugged into the circuit. So when a plug is out, that resistor is not part of the circuit. And when a plug is in, that resistor becomes part of the resistance provided by the resistance box. Now, given the resistance box on your screen, the resistance supplied to the circuit is equal to 5 plus 10 plus 50 ohms, which is equal to 65 ohms. Now, those are two of the ways you can generate specific variable resistances in the laboratory. Keep learning.